Now there is a question. Three blocks. There is a pulley, block of mass m1, m2 and m3. These three masses are there, and two pulleys, pulley 1 and pulley 2, and the relation is given m2 is greater than m1 is greater than m3. Okay, the question here is find the acceleration of the blocks and tension in the each rope. Tension in each row. These are easy questions, but as of now we'll solve. Let's draw a free body diagram first. Free body diagram for m1. There are two different ropes. In this rope, let's assume the tension T1, in the rope tension T2. Generally, students may do mistake. They consider T1 here and T2 here. Why? It's wrong, because T1 and the rope is same rope passing over the pulley, and this is a massless rope. For a massless rope, the tension will be same throughout its length. And this rope is different, this rope is different. Two different ropes, first and second. There are two different ropes. So for the tension 1 will be in the first rope, tension 2 will be in the second rope. We should not intermix these two again. Now, if you draw a free body diagram, T1 in the upward direction, M1G in the downward direction. First, second, M2, T1 in the right direction, T2 in the right direction. Next, third, M3, T2 in the upward direction, M3G in the downward direction. Very good. We draw the free body diagram. Now the problem comes which direction they are moving. Acceleration is in the downward direction or it is in the upward direction. We don't know this. To know this, we gave the relation m1, m2, m3 relation. m2 is greater than m1 is greater than m3, which means this m1 is greater than this m3. So what happens to this body? Then what about m2? This is on a frictionless surface, nothing to worry about it. Its mass, its mg, m2g is in I think downward direction. We don't need to bother unless there is a friction here. It's a frictionless surface. So now the acceleration will be in the downward direction in the m1, m1, and acceleration towards the left, acceleration towards up, acceleration in the upward direction. If we write the equation, which force is more, T1 is more or m1g is more? Which direction the body is moving? Downward direction. Which force will be more? m1g minus T1 is equal to m1a1, first expression. So T1 minus T2 is equal to m2a. Oh, it's not a1, m1a, m2a 2. And the third case, this is the second case, this is the first case. So it is going upward, T2 minus m3g is equal to m3a. This is the third expression. How many equations we have? 3 equations. How many unknowns you have? Let's calculate what are the unknowns. T1 is unknown, acceleration is unknown, T2 is also unknown, acceleration is also unknown. So 3 equations and 3 unknowns are there. Let's solve these equations. And at the end of the class, we'll have a shortcut to solve these problems. Equation 2 plus equation 3. Let's do. Then the T2 term gets cancelled. T1 minus m3g is equal to m2 plus m3 into a. This is the fourth equation. Then equation 4 and plus equation, I will write the equation 1 here. Equation 1 is m1g minus T1 is equal to m1a. Equation 1. equation 4 plus equation 1 if you do, then m1 minus m3 into t1 gets cancelled is equal to m1 plus m2 plus m3 into a. Then a is equal to m1 minus m3 over m1 plus m2 plus m3 multiplied with g. This is the acceleration to get the tension T1. Substitute it in equation 1. Substitute in equation 1. So m1g minus T1. T1 becomes m1a1. m1a. A is equal to m1 minus m3 over m1 plus m2 plus m3 multiplied with g. Okay. m1 square plus m1 m2 plus m1 m3 minus m1 square minus m1 m3 over m1 plus m2 plus m3 multiplied with g. What gets cancelled? m1 square, m1 m3. Anything we are missing? No. It is equal to m1 m2 m1 m2 over wait a minute, m1 m3 there is a plus, it's not, doesn't get cancelled. Okay, and this minus, if it goes inside, plus m1 m3 it becomes minus m1 square plus m1 m3, m1 square and m1 m2 and m1 m3 minus m1 square plus m1 m3 into g. m1 m2 plus m2 m1 m3 over m1 plus m2 plus m3 multiplied with g is the T1. Okay, and the simple way to solve this problem. While solving this problem, it is very easy. Let's see how to solve. Instead of solving 3 equations, we'll get in a one step, single step. m1 m2 and m3. We know m1 is greater than m3, we know, which means the block move in this direction. Obviously they move in this direction. Now I am drawing, they are like a single row, m1 m2 m3. What is the force that is acting in the downward direction? m1g. Tension T2 will be there anyhow. There is another force m3g in this direction. If you take all the blocks as single system, then it becomes m1 plus m2 plus m3, because this surface is frictionless, and in this direction m1g, in the other direction m3g. So let's acceleration a is equal to, in the left direction, because m1g minus m3g is equal to m1 plus m2 plus m3 multiplied with a. A is equal to m1 minus m2 over, m3 over m1 plus m2 plus m3 multiplied with g. This is how we'll get acceleration directly. We can directly say m1g minus m3g by total mass, sum of the masses. Okay, this is one example which can be discussed.